Welcome everyone. So in this video, we are going to look at how to configure the VRFs now. So I'm going to configure my customer one in this video. So I'm going to configure between these two and these two. At the end of this video, my R5 should be able to communicate with R8. So let's go ahead into the configuration now. So I will bring up my notepad. All right, so on R1, I will say that VRF definition C1. Okay, that's my VRF name, that is C1, and I'm giving an RD value of 100:1, and I'm saying that address family IPv4 unicast, and I'm saying that route target value will be import. So route target import 100:1, and route target export value will be 100:1. Basically, what I am saying is that whenever you want to exchange the route, use the RD route distinguished value as RD 100:1, and whenever you want to communicate between different VRFs, do the route target value as 100:1. Right. So this will we will be looking into this one in detail when we come to the route leaking at the end of the series. Okay. So let's go ahead and copy paste on the VRF. Let me check whether we do have any command issues. No issues, that's all. Next thing is that I need to configure the interface E0/1. So I will say that interface E0/1 VRF forwarding will be C1, and IP address is 200.5.5.1 250.250.0 and no set and exit. And also I am having a normal eBGP between my customers. So I'm saying that router BGP 100 address family IPv4 VRF C1. Now I have to define my neighbor within the VRF C1 because this interface is inside the VRF C1, so that's the reason I have to define within the VRF C1. I am saying that neighbor 200.5.5.5 remote AS at 65,001. All right, and exit. That's all. Let's go ahead and do the copy paste of and on R1. No errors. So let's do the customer's edge, that is R5. So nothing has been configured. So I'm saying that config key interface E0/0 IP address will be 200.5.5.5 255.255.0 and no set exit interface loopback 0 and IP address will be 10.5.5.5 to 55.255.0 interface loopback 1 IP address will be 10.1.1 and I'm saying that router BGP 65,001 address family IPv4, and now you see that I am just enabling the address family IPv4 because the customer has no idea whether the service provider's edge is configured with the VRF or not. So customer has no idea. So you just do the normal configuration on the customer's edge side. So I'm saying that first I will advertise the network, that is network 10.5.5.0 with mask 255.255.0 and network 10.1.0 with mask 255.255.0. Next I will define the neighbor, that is 200.5.5.1 with remote AS as 100 and exit. Right, so let's do a copy paste. So I will just do the IP addresses first on R5, and next let's go ahead and do the BGP configuration. Now once my BGP is up and running, I should see the routes in the R1. So in my R1, what I should see is that in the VPN v4 table. So in the VPN v4 table on R1, under the route distinguished value of 100:1, I should see the routes coming as 10.5.5.5 and 10.1.1.1. So this is what I have to see. So you see that my BGP is up and running. So I'll go to R5, and if I say that do show BGP VPN v4 unicast all, this is the command. And you see that 100:1, that's the route distinguished value. And what we are seeing that two routes. Now, R1 is seeing the routes coming from the R5, that means coming from the customer. So it will automatically forward it to R4 because it's an iBGP neighbor. So I have to see the same routes on R4. If I say that do show BGP VPN V4 unicast all. Still I did not receive it, just give some time. Do clear Mpbgp sock. So just give it some time and you should receive the routes on R4 also. Right, so you see that still I am not able to receive. The reason is that I do not configure any VRF on it. So on R4 there is no VRF configuration yet. So once I do the configuration, then only the VPN v4 will be enabled. So let's do the configuration on R4. I will just bring this one to this side and I will go back to my R1 and do a copy paste because it's the same configuration almost. And this one should be R4. Now, before I do any of this configuration, so what I will just do a VRF configuration. So once the VRF is up and enabled, it will automatically should show the route. So let me do a copy paste before I do the ending of the configuration and do show BGP VPN v4 unicast all. Now you see that I am getting the route. Now the reason what it was happening is like R1 is saying that I do have a VRF which consists of route distinguished value of 100:1 and there was no VRF, so there is no import of 100:1. Route target, no, there is no import of route target 100:1, so that's the reason you do not see this route. So once I configured the VRF saying that VRF C1, now export and import the RT value of 100:1. So that's the reason now I am seeing the routes on R4. Now let's go ahead and complete the configuration now. Okay, so now E0/1 VRF forwarding is C1 and 200.8.8.4. And BGP, the router BGP 100, 200.8.8.8. So that will be my customer's edge, that is the R8, and the BGP AS value is 65,001. Right, so let's go ahead and do the copy paste on R4 now. So let's do the R8 configuration, that is my customer's edge. So I will go back to my R5 and I will say that this one is 200.8.8.8 and I am 10.8.8.8 and 10.2.2 and 65,100. Network will be 10.8.8.8 and this one will be 2.2 and my neighbor will be 8.8.4. and let me go ahead and do the configuration now. So once this configuration up and running on R8, now once the configuration is up and running, so I should see both the routes, that is 100:1 I should see what 10.5.5.5, 10.1.1.1, 10.8.8.8 and 10.2.2.2. So these four routes should be seen in the VPN v4 of R1 and R4. And similarly, once this, when you have these values over R1 and R4, that is my provider's edge, so automatically it's an eBGP behavior that it will be transferred to the customer's edge. So customer should see the routes, R5 should see the routes of 10.8.8 and 10.2.2 coming as an BGP routes. And again, similarly on R8, 10.5.5 and 10.1.1 should be a BGP routes. So let's go ahead and check whether we got the routes on R1 and on R4. I will go to R1 first and I will say that do show BGP. Right, so before that, let me go to R4 and see that BGP is up and running. So if I say that do show BGP VPN v4 unicast all, you see that all the four routes have been seen on the R4. That means I should see all the four routes on R1 too. I'm able to see all the routes on R1. Let's go to R5. So I should see the R5. I should see the BGP routes as coming from R8. If I say that do show IP BGP, you see that I'm not able to see the routes. Right. So similarly, if I go to R8, if I say that do show IP BGP, I am not able to see the routes coming from R5. Now the reason for that one is that if you look at the AS number over here, the AS number is same, so that means the BGP will decline. It will decline the prefix coming from the same autonomous system number. So what we can do is like either on customer's edge we can say that AS number allowed, or on the provider's edge what we can do is that AS number override. Basically what you are saying is that this neighbor, whenever this one is sending the prefix, on the customer edge we are saying that neighbor so and so AS number is allowed, the same AS number. But we can fix it on the provider's edge, that is with respect to the ISP or the service provider. On the provider's edge we will say that neighbor from 200.8.8.8 AS is override. So this will override the AS. So basically this one is the preferred one. So I will do that one, the preferred one. I will bring up my notepad and I will go to the R1 and I'm saying that router BGP 100 address family IPv4 VRF C1 neighbor 200.5.5.5 AS override. That's it. Do the copy paste on R1. So once this is done, R5 should see the routes. So if I say that do show IP BGP, so if I say do clear IP BGP star, so you see that I'm able to see the routes. Now if you see that it has override the AS number as 65,102 back to its own AS number, that is 100. So let's do the same thing on R4. So I will do the same thing on R4. So I will say that this one is 200.8.8.8 and that's it. So once this has been done, let's go to R8. Before we cannot see any routes. And if I say that do clear IP BGP star soft and do show IP BGP, and now you can see that I can see the routes coming from R5. So let's do the ping, do ping 10.5.5.5 with source loopback 0, I'm able to ping, and do ping 10.1.1.1 with source loopback 0, I'm able to ping. And let's do the trace route and see whether the labels have been assigned or not. Do trace route 10.5.5.5 with source loopback 0. And now you can see that from 103.3.3, everything is being labeled until we reach the next provider's edge. So basically what is happening over here is that, let me erase this one first. Right. So my traffic is coming in, and once it has been coming in the cloud, in this service provider cloud, I'm running Mpls. So it is traveling on the Mpls label. So it is traveling on the cloud. So instead of checking the IP address, now it is checking the Mpls label and forwarding the table. And if you go to R2 and R3, they don't have any knowledge about no routes to R5 and R8. So let's go to R2 and R3 and verify that one. If I go to R2 and if I say that do show IP route, and you see that I don't see any routes going towards my, that is 200.5.5.5, neither 200.8.8.8, neither I do have .10.5.5, nothing. But still, without having the routes on my provider's edge, that is core, still I'm able to communicate between two branches. So this is known as Mp-Bgp. So now we have done the configuration with respect to the customer VRF. So in the next video, we are going to configure the VRF C2. I hope you have enjoyed this video. See you in the next video.